Let's take a look at instructional strategies for conversion. For each one of these slides, it's going to walk you through steps that I want to point out. One, students need to experience this before we just present them with this anchor chart. We want to make sure that our students are having access to visual models beyond just images. Images are okay if that's all that you have. However, encourage your students to bring in some of these items. Maybe you'll give them some PBIS points for doing so. Most students in your class will be able to show these items, such as a thumb. Maybe somebody has an old license plate. That's interesting. How many PBIS bucks would you get for that? A yard, a mile, the distance you should be able to walk within 20 minutes. Okay? We're determining if you're converting from a greater unit of measurement to a lesser unit of measurement or vice versa. This page talks about weight. Step 2, you're using the greater unit of measurement to determine how many of the lesser units it would take to make the greater unit of measurement. If you're converting to a greater unit of measurement into a larger unit of measurement, you must multiply the greater unit by how many of the lesser unit makes one of the greater unit. Or if you're converting a lesser unit of measurement into a greater unit of measurement, then you divide the lesser unit by how many of the lesser unit makes one of the greater unit. So you can visualize it like this: cup, pint, quart, gallon. And again, encourage your students to bring in these items. What would a gallon be? What would a quart be? What would a pint be? What would a cup be? Of course, give them parameters about what they're bringing in. And then we have time. So you'll notice how these steps are all similar, but what's different is what students are being asked to convert. Sometimes it's time, sometimes it's liquid or volume measurement, weight, or linear measurement. We also take a look at students determining the area and the perimeter. I really want to stress that even though this is listed here for the students, it is not what you're leading with. You're literally building this as students are uncovering and discovering what the formula for area and perimeter is, or even taking out the word formula. How are we finding the area and the perimeter of rectangles? What a great learning opportunity for students. Then they need to determine the type of angle. Compare the angle that they see formed by the corner of a piece of paper, because that's going to be their 90-degree angle. If it looks the same as the angle on a piece of paper, then it's most likely a 90-degree angle. That's step 2. If it is narrower, meaning a little smaller, if it's narrower than an acute angle, this means that it is less than 90 degrees. If it's wider, then it is an obtuse angle, which means that it is greater than 90 degrees. Measuring angles using a protractor. Step 1, you're going to determine if the angle is right, acute, or obtuse. Line the protractor up or the angle up one of the rays opening upward and extending the line if necessary. How are they extending the line if necessary? Is that an instructional implication? Are they just guessing? Well, if you see a student not doing this correctly during class, then you have the opportunity to guide that student into saying, is there something you can use to extend that line on your desk? Right? Or pick up this paper, man. Line this up. That's different. We want our students to, once again, I'm going to say it again, we want our students to construct their knowledge. They get to build their own knowledge. So we're asking those guiding questions to help improve their understanding. If the angle is acute, then select the degrees that are less than 90. If the angle is obtuse, then they select the degrees that are greater than 90 degrees.